For number 4 of 2019, you should have already done this, so please pause the video and complete it before you watch this video. But with that said, number 4 says a cylindrical barrel with a diameter of 2 feet contains collected rainwater, as shown in the figure above or to the side. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time is modeled by dH dt, where h is measured in feet and t is measured in seconds. And then it gives us the equation for the volume of a cylinder. All right, for part A, it says find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. So we're looking for the rate of the volume with respect to time. Well, we're given a differential equation here that is relating h to t, so that doesn't really have anything to do with volume. Here, this is why they gave you the equation for volume, and it's kind of nice. They didn't have to do this. The formula for the volume of a cylinder should be known by now, but we are looking for the rate of the volume in respect to time, which means we are looking for v prime of t, or another way of saying that is dv dt. So that tells us that our variable is going to be time, which implies that our radius and our height are actually functions of time. They're not just variables. So we're going to start off by noting that it says we are looking for that rate when the height is 4 feet. So I wrote that down just as a side note. And then now let's go ahead and take the derivative here. The derivative of v is v prime, and remember it's in terms of t, so I should have maybe said dv dt. To take the derivative of this side, well, the derivative of this side, notice that this is a product here. Now I'm going to break up the product into two this way. I'm going to say that this is my first piece, and then this is my second piece. And you could have done it a little bit different. You could have taken the pi as a constant out. And there's actually something else you could have done, and we'll talk about that in a minute. But the derivative of the first part, so the derivative of pi r squared, is going to be 2 pi r, okay, and then times r prime, because again, r is a function of time. So times r prime, and then times the derivative, then times the second thing, which is h, and then plus the derivative of the second thing, which is going to be h prime, because it's in terms of time, and then times the first thing, so pi r squared. So that's just the product rule there. From here, I'm going to just plug in the values that I know in order to figure out what v prime is. So here we're going to get 2 pi times the radius. Well, what's the radius? The radius, because it says up here the diameter of that cylindrical barrel is 2 feet, the radius is going to be 1. And in fact, the radius is always going to be 1 because this is a cylinder. It's not changing. So the radius is 1. So that brings up the point, what is r prime? Well, r prime is the rate at which the radius changes. Since the radius isn't changing, we would say that r prime is 0. Now we know what h is. H is 4, but we didn't actually need that at all in this case because r prime is 0 here. And then h prime, well, how do I find h prime? H prime is the rate of change of the height in respect to time. Well, that was given here, dH dt. So I'm going to go ahead and use this differential equation to figure out the derivative of h at the time, at the time when h equals 4. So that's going to be negative 1/10 times rad 4, because I just plugged in 4 for the height here, and then that simplifies to negative 1/5. So I can plug that in for h prime. And then it would be pi times the radius, which is 1 squared. And then we simplify all that. That first bit completely cancels out, and then the second part simplifies to just negative pi over 5, or negative 1/5 pi. And then the units on this are going to be feet cubed per second, because we're looking for the rate of the volume in respect to time. So volume is feet cubed, and the time in this case was measured in seconds. Another way to approach this would have been to recognize that in this volume expression, since r is constant, I could have plugged in 1 initially. So I would have just gotten volume equals pi times h. and then taking the derivative of that in respect to time. And that would have made it maybe a little bit easier to do. But again, that only works if you have a function that's constant. So I just prefer to do it this way, so I'm asking myself these questions as I go along. As far as points go on this guy, you're going to get 1 point for your dv dt, in other words for your v prime function, so all of this, 1 point for this equation right here. You're going to get 1 point for your final answer, and your units have to be correct to get that point. For part B, it says, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Now this is interesting. We've done a couple problems like this, but notice it is asking for whether the rate is increasing or decreasing. How do I know when a function is increasing or decreasing? Well, I know a function is increasing or decreasing when its derivative is positive or negative. So because I'm asking for whether the rate is increasing or decreasing, I have to take the derivative of the rate. So I have to take the derivative of h prime of t, or the derivative of dh dt. So the derivative of that would be the second derivative of h, essentially. So here we're taking the derivative again, the second derivative in respect to time. So when we take this derivative, it's going to be negative 1/10 times 1/2 h to the negative 1/2, and then we have to use a chain rule, so it's going to be times the derivative of h, which in this case is h prime, or we could call it dh dt, that's fine. And then from here we're going to plug in what we know. Well, if I'm going to evaluate when h equals 3, because it says is the rate increasing or decreasing when the height is 3, well, I can plug in 3 just fine to h, but then I have to figure out what h prime is. Well, I'm going to figure out what h prime is by plugging in 3 to this equation up here, and so we end up with negative 1/20 times 3 to the negative 1/2, just by plugging in 3 there, and then we're plugging in 3 to our differential equation for dh dt, and so we end up with negative rad 3/10 essentially. Okay, and then we simplify all of this. We notice that the rad 3's are going to reduce here. So what did I do? I rewrote the 3 to the negative 1/2 to be a radical 3 on the bottom. We'll notice that the rad 3's reduce. The negative times the negative is a positive, and then 1/20 times 1/10 is 1/200. So now I know that the second derivative is positive, which means the first derivative is going to be increasing. So that would tell me that the rate is increasing because its derivative, d2h over dt squared, is a positive value, or greater than 0. As far as points go on this guy, you're going to get 2 points for the second derivative, so 2 points for this line here, and my guess is you would get 1 point if you just did negative 1/20 h to the negative 1/2, and you would get your second point when you multiply by h prime or dh dt, because they wanted to make sure you were doing this in respect to time. And you're going to get 1 point for your answer with your justification, so stating that that second derivative is positive there. For part C, it says at time t equals 0 seconds, the height of the water is 5 feet. So that's an initial condition there. Use separation of variables to find an expression for h in terms of t. So we're trying to create an equation for h. Well, this is a differential equation. How do I solve it? I separate the variables. So in this case, the first thing I'm going to do is multiply by dt, and then I have to move this rad h over to the other side, so I'm going to divide by rad h. So I end up with 1 over rad h dh equals negative 1/10 dt. The next step here is going to be to integrate, and again, a common mistake I see all the time is, oh, that's 1 over something, so it's going to be the natural log of rad h. No, because the exponent, for that to be true, the exponent in the denominator has to be 1. In this case, the exponent in the denominator is 1/2 because of the radical. So what I need to do is rewrite this as a negative exponent, so it'll be h to the negative 1/2 dh equals negative 1/10 dt. And then we'll integrate. The antiderivative of h to the negative 1/2, well, we're going to add 1 to the exponent, and then we got to deal with the coefficient out front that will cancel that out, so that's going to be 2. again, take the derivative of this to make sure it matches our integrand, and it does. The antiderivative of negative 1/10 is negative 1/10 t, and then don't forget the plus c. Now we'll plug in our initial condition. Our height is 5, and our time is 0, so that'd be 2 times 5. Sorry, I rewrote that as a radical again, because h to the 1/2 is rad h. Anyways, plugging in the initial condition, you get 2 rad 5 equals negative 1/10 times 0, and so that tells us that c is 2 rad 5. Then I'm going to take that and plug it back in to my equation here. So I get 2 rad h equals negative 1/10 t plus 2 rad 5. And then from here I have to solve for h. So I'm going to divide by 2 on both sides. So I end up with rad h equals negative 1 over 20 t plus rad 5. And then I'm going to square both sides. So we end up with h equals negative 1 over 20 t plus rad 5 all squared. Points on this guy, you're going to get 1 point for separating the variables. You're going to get, so this line right here, if you got to this line, you got 1 point. You're going to get 1 point for the antiderivative of both sides. So you have to have the antiderivative on both sides to get that point in this case. You're going to get 1 point for the plus c and finding c. So if you put plus c and then you got down to c equals 2 rad 5, you got that point. Even if you got c equals 2 rad 5 and you didn't put plus c here, you do not get this point, and you do not get any other points from here on out. That plus c is important. And then you're going to get 1 point for your final answer of solving for h. Remember, you can't leave it like this. You can't leave it like this because that's not solving, that's not doing what it asks you to do. It says find an expression for h. So we have to isolate h there. So that is part C. That wraps up this problem. Go ahead and grade it, and then the next problem we're going to do is a quiz. It's going to be number 6 from 2018. It's a non-calculator problem, as most differential equation problems are. Do this, set a timer for 12 minutes, do it on your own. Please have integrity when you're doing it, and then come back and watch the video to grade yourself.